Few weapons in World War II inspired more fear or respect than the German 88mm Flak Gun. It was a masterpiece of engineering, and in the hands of a trained crew, it became one of the deadliest machines on any battlefield. Tens of thousands of Allied airmen, sailors, and soldiers never made it home because of what this gun could do. Today, we're going inside the engineering that made the 88 so devastating and discussing why its ground attack role changed warfare forever. The German 88mm Flak Gun stands as one of the most iconic and adaptable weapons produced during World War II, deployed on diverse fronts such as North Africa, the Eastern Front, and Western Europe. Its versatility ensured that it remained a pivotal asset throughout the entire war and remained in service for several decades following the end of World War II, seeing active service with several nations. In this episode, we will be covering the 88mm Flak Gun's mechanical function and its role as a ground attack weapon. We will be examining a Spanish-built FT-44. These guns were built under license from Rheinmetall at the Trubia munitions plant. This 88 was built in 1944 and is number 130 out of roughly 200 guns built by Trubia. In our previous episode, we looked at the 88's development, history, design of the gun, and its role in air defense. We looked at its many adaptations and briefly touched on the gun's operation. If you missed our first episode, I really encourage you to go back and check it out. So how does this 88 work? Well, let's break it down into manageable components, starting with the gun cradle, examining recoil management. The recoil system of the 88mm Flak Gun must withstand the recoil forces of the fired shell, which is plunging 3,000 pounds of iron to the rear of the gun and then must return all that weight back to battery. If you're not familiar with the term battery, it simply means that the barrel and breech assembly have returned to their firing position. Now, the cylindrical-looking device at the top of the barrel is what is called the recuperator cylinder. The job of the recuperator cylinder is to bring the gun back to battery, and we'll explain how this works. Inside, there are two cylinders, a liquid cylinder and a gas cylinder. The liquid cylinder contains 4.5 gallons of a 60% glycerin, 40% distilled water, and 1 ounce of caustic soda per 3 gallons of liquid solution. The second cylinder is gas-filled with 600 psi of nitrogen. The liquid cylinder sits within the gas cylinder, both running in parallel with one another. The 88's recoil forces the recuperator cylinder rod and piston to the rear of the gun. The liquid solution is transferred by the piston from the liquid cylinder into the gas cylinder, compressing the nitrogen, absorbing recoil energy. Now, as the 88 begins counter recoil, the nitrogen begins to expand, forcing the liquid solution back into the liquid cylinder, driving the piston and rod back to its neutral position. There are 3 ports on the back side of the recuperator cylinder. On the top left is a gas valve used to bleed pressure. The top right is the gas and liquid fill port, and the lower left being the drain port. Now, while all of this is happening up here, the recoil cylinder located beneath the barrel is doing its job of dampening the force of the recoil. The recoil cylinder, having no pressurized gas, is filled with 2.5 gallons of an identical liquid solution held at atmospheric pressure. As the gun travels in recoil, the fluid is forced through the orifices in the piston head and through the control grooves in the recoil control rod. Now, the pressure of the liquid solution flowing through the constantly narrowing grooves takes up much of the recoil and gradually brings the gun to a standstill. These 2 fill ports on the top of the cylinder are where you fill the recoil cylinder with the liquid solution. The recuperator cylinder controls a portion of the recoil energy, and the recoil cylinder controls the remainder of the recoil energy and the length of the recoil. Now, this scale is a recoil marker scale. It is used to keep track of the length of recoil. Excessive readings could indicate a malfunction of the recoil and/or the recuperator mechanisms. The recoil travel at 0 degrees elevation is approximately 41.5 inches. Now, the recoil travel at maximum elevation is approximately 28 inches. Now, you might be asking yourself, well, how is it that there is less recoil travel at maximum elevation versus a more horizontal firing position? This could be answered by a mechanism referred to as the recoil control linkage. This linkage automatically adjusts as the cradle is elevated, effectively metering the porting inside the recoil cylinder. If the gun was fully elevated when fired, the action of the recoil would slam the breech right into the carriage. Therefore, the length of the recoil travel had to be reduced. As we look at the barrel, the Flak 18 barrel consisted of an outer jacket, mainly to protect the full-length inner liner, which is the rifled portion of the barrel. The rifled portion is then attached to the removable breech. The one-piece rifled section is what is referred to as the monobloc. The original Flak 18 monobloc barrel was considered out of spec and needed replacement after 1,000 rounds. To address this, Rheinmetall developed the RA9 multi-section barrel. This new design allowed replacement of only the worn, rifled sections of the barrel, a cost-saving measure that for many reasons in its application just wasn't very practical. Both monobloc and modular barrels were interchangeable among Flak 18 and 36 models. Dimensionally and ballistically, they were identical. Let's take a closer look at what the engineers at Rheinmetall referred to as a modular barrel. This multi-sectional barrel consisted of 5 components. The first section being the outer jacket. Its main purpose remains identical to the monobloc barrel to protect the inner liners. The second section is an inner liner which locks the 3-piece inner sleeve together. The 3-piece inner sleeve sections being the rifled portion of the barrel. The RA9 designs proved to be effective, but as one can imagine, the precision engineering and the tight-fitting tolerances required at the time of assembly were not always ideal under field conditions. Now, the rifling within the barrel is cut at a right-hand spiral twist, 32 grooves in all. The twist rate is rather interesting because it starts out with a slower 1-turn and 45 calibers at the breech, then increases to a faster 1-turn and 30 calibers towards the muzzle. So what does that mean? It's referred to as a dual or progressive twist rate. The function of the dual twist rate is to stabilize the projectile in flight. A sudden spin from a faster twist rate could possibly damage the shell's driving bands. The dual twist rate eases the projectile into a spin, improving accuracy and reducing the mechanical stress on the barrel's rifling, prolonging the life of the barrel. Advancements in powder propellant and improved ammunition designs also contributed to longer barrel life. As the war progressed, a 2-section barrel was produced, and eventually the manufacturers went back to the monobloc construction by 1943. The breech mechanism can be described as a horizontal sliding breech block, actuated by a breech operating spring permitting semi-automatic or manual firing operation. At the top of the breech, there are several components facilitating the breech's operation. Here we have the cocking lever. It functions as the safety for the gun. In its rear position, the gun is on safe. In its forward position, the gun is considered ready to fire. Next, we have the breech operating handle. It not only performs the act of physically opening the breech, but it also performs the function of determining the gun's semi-automatic or single-shot operation. The handle assembly also contains an upper and a lower operating spring within its housing. The catch located at the rear of the breech, depending on its position, is what determines the mode of operation. In semi-automatic mode, when a shell is chambered, the rim at the rear of the shell case activates the extractors. This action allows the breech block to close under the action of the lower breech operating spring, which is located within the handle housing. Once the gun is fired and begins its recoil cycle, the breech passes by a cam, seen here on the right side of the gun. The cam engages a shaft that in turn winds up the breech opening spring. The catch on the spring cover then disengages and the lug retaining the breech actuating mechanism closes in its down position. Once this occurs, the breech, now under tension from the spring being wound, is free to open and eject the spent shell case. As the breech returns to battery, it remains open due to the extractors engaging with the recesses that are machined into the breech block. The extractors are securely positioned by the tension of the upper spring with the breech operating handle. This upper spring has also been wound by the action of the cam. Now the gun is ready for its next shell. Another action is taking place during the recoil phase, the cocking of the percussion mechanism, or what one might refer to as the firing pin. It is automatically cocked as the breech is opened. As a new shell is inserted, the breech automatically closes, allowing the percussion mechanism to spring forward and fire the round, starting the semi-automatic process over again. Now in the gun's manual firing mode, the loader would manually operate the opening of the breech, load a shell, which would then trip the extractor fingers, allowing the breech to close automatically. To fire the shell, the loader actuates the safety lever and one of the two firing levers. The lever on the left side of the upper gun mount serves as the primary, and the firing lever on the right side of the mount serves as the secondary. An additional mechanism, the handle furthest forward on the breech, is the extractor actuating lever. In manual firing mode, once a round is fired and the breech returns to battery, the breech must be opened manually to eject the spent case. Once open, the breech remains open in a locked position. The extractor actuating lever must be operated to close the breech if the extraction fingers are not tripped by loading a new shell. Now as we make our way further down the upper carriage, we have two spring equalizers. These equalizers balance the gun's weight towards the muzzle. Inside these telescoping housings are three coil springs separated internally by spacers. The tension on these springs is adjusted by a rod acting as the spring compressor and adjusting screw. This balancing of the barrel greatly increases the ease of operation when either elevating or lowering the barrel. The upper carriage also contains the sighting and fire control mechanisms, the heart of the gun, so to speak. As one can see here, there are several hand wheels, dials, instrumentation, hand cranks, optical devices, a bell, a pair of seats, and electrical outlets. Each device is essential for the gun's function in both anti-aircraft and ground attack roles. These two electrical sockets are for K1 and K2's headsets, allowing data to be transferred verbally from the director. K6, the fuse setter, also has a socket for a headset. What we're looking at here is called the follow the pointer system. And the way this works is data is sent to the gun from the fire control center. And what happens here is this single pointer will begin to move according to the data being sent to the gun. And what K1 and K2's responsibility is to simply turn their hand wheels in both azimuth and elevation and match the pointer, having both a low and a high gear setting. This lever is what changes the gear settings. In the hands of a skilled operator, time to traverse 360 degrees in high gear is 34 seconds. In low gear, 70 seconds. An additional dial indicator keeps track of the gun's 360-degree rotation. The 88 could only rotate 360 degrees twice in either direction. There are stops that prevent the gun from over-rotating, as doing so would damage the internal wiring. To raise the gun from 0 degrees to its maximum elevation of 85 degrees, in high gear it takes 15 seconds, and in low gear it takes 26 seconds. Now the fuse setter is an interesting piece of equipment. This is the Flak 37 fuse setter. The graduations represent a numerical value of degrees, indicating the time of flight for a fired shell. In contrast, American fuse setting devices read numerical values in seconds and not in degrees. Just as K1 and K2 align their pointers, the fuse setter, K6, aligns his pointers up with the data being transmitted from the director. This cranking handle on the side of the fuse setter rotates the inertia flywheel, which stores up mechanical energy for cutting the fuses. K6 rotates the handle at a uniform rate each time a round is inserted into the cup. The handle at the front of the setter releases the shell from the cup after the fuses have been cut. Now the bell mounted on the upper carriage is an odd sight, but it is an important communication device. The bell could be heard over the noise and delivered essential instructions to the gun crew. It could be used to command fire, dictate firing intervals, or other agreed procedures. Moving on to the lower carriage, we have the gun's pedestal. This pedestal, although looking benign, contains several key components. First, it houses an additional gun leveling mechanism. This mechanism allows further fine-tuning or leveling of the upper carriage. Adjustments are made with these two hand wheels, providing 4.5 degrees of adjustment respectively, essentially acting as a gimbal. Second, sitting atop this leveling mechanism is the traversing ring, which allows the gun to traverse in a 360-degree arc. All these components are then anchored to the cruciform platform. Now, these two outriggers must be deployed, even if the gun was being fired sitting on its wheels. You'll notice that the two outriggers, along with the cruciform fore and aft spars, have leveling jacks. These jacks perform the duties of leveling the gun. Two stakes are carried on each outrigger, one for the outrigger and the other for the corresponding spar, providing a stable platform from which to operate the weapon. This storage box holds the direct fire optical sight. Directly below it is the main electrical data connection plug. This plug, when connected, allows the fire director to transmit firing and fuse setting data to the gun. Positioned on the spar is the gun's travel lock. On both Flak 36s and Flak 37s, this can be positioned on either spar. The crew would lock the barrel into position for travel or long-term storage. A collar on the barrel for connecting the travel lock prevents undue wear to the barrel's outer tube. This is the 202 special trailer. Situated atop of the 202 bogie assembly's fenders are storage boxes, cable spools wound with data transmission cables, hand tools, cleaning rods, and the brakeman's seat. Centered between the fenders is the hand-operated winch used to raise the spar off of the bogie locking hooks. On one side of the winch is the brake handle, and below the brakeman's feet are two large pry bars. And here we have our airline couplers, along with the bracket holding the brakeman's brake light. Wheel blocks are mounted to the outboard side of the fenders, and this lever here is what couples and uncouples the bogie assembly from the spar pins. This is the tow bar along with its locking mechanism. The locking mechanism locks or unlocks the steering axle, allowing the gun to be towed either breech or muzzle forward. There are two tow bars, one for each bogie assembly, allowing the bogie units to be coupled together as one unit. We are going to demonstrate how to go from the 88's travel position to its ground mount by removing the gun from its trailer. So in order to fire this gun, whether it's sitting on its bogie assembly or we have the gun sitting on the ground, we have to lower these outriggers. There's one on each side of the gun. Okay, I'm going to pull the lock pin. Okay, lock pin is pulled. Safety chain is off. Coming down with the outrigger. Oh yeah. Okay, once the leg is down, we still need to lock it in place. So this handle is what locks it in place, and we'll rotate this right to this position right here. And there you go, coming down. With the outriggers in place, we're going to finish removing the 88 from the trailer. Right here where this red handle is the clutch lever. And what this clutch lever does is it disengages the elevation arc when the gun is in its travel position. So we want to make sure that we engage the clutch, which in this upper position the clutch is engaged, so that we can then raise the barrel. And then we can lower the travel lock. With all these moving parts, sighting and firing controls, how many crew members does it take to operate this thing? 10. Yes, 10 crew members referred to as cannoneers. Now, cannoneers is spelled with a K in German, so each position is assigned a number, K1 through K9. The detachment commander or gun commander is not assigned a number, making him the 10th member of the gun crew. These assignments were very regimented. Procedures were carefully governed by their assigned crew numbers. Some cannoneers' positions were target-specific. Their assignments and responsibilities may change depending on the type of engagement. K1's position is responsible for the guns laying in the horizontal. K2's responsibility is to set the elevation azimuth, and K3 is the loader and trigger puller. These three positions generally remained constant. For ground targets, K4 through K7 are responsible for handling the ammunition. K8 acts as the range setter, using one of the portable ranging devices, and K9 as the lateral deflection setter. For air targets, K4, K5, K8, and K9 handle the ammunition. K6 is the fuse setter, and K7 handles ammunition for the fuse setter. K9 is available to handle additional ammunition if needed. In the direct fire role, K2 would operate the azimuth control hand wheel, tracking the target through the optical sight. Two direct fire sights were available, designated the Flak ZF.20 and the Flak ZF.20E. Both sights shared similar characteristics, having a fixed 4-power telescope, lateral and vertical deflection scales, a partial crosshair reticule with an inverted V aiming point, and illumination of the crosshair capabilities. Two additional interesting features were the blank eye shield, greatly reducing operator eye strain. Secondly, sighting in varying lighting conditions was aided by 4 lens filters. A clear, a green, a light neutral, and a dark neutral could be rotated into the viewfinder. The ZF.20E was different only in that it had a ranging drum, its graduations in hundreds from 0 to 9,400 meters. K1 simply had to line up the elevation quadrant by rotating the hand wheel, matching the pointer being manipulated by K2 adjusting the optical sight. The elevation quadrant graduated in 0.025 degree intervals from -3 degrees in depression to 85 degrees in elevation. Now, if a round had not already been loaded, K3 on command would then load and fire the gun. An additional sighting device is the Panoramic Telescope 32. This telescope, mounted over top of the recuperator cylinder, was used for orienting or zeroing the gun with the stereoscopic director for indirect fire against ground targets. All guns in the battery needed to be set to the same zero. The maximum range, 11,445 yards with time-fused high explosives, and 16,132 yards with a percussion-fused high explosives. When calculating range to target, several models of handheld stereoscopic rangefinders were used. The rangefinder Model 34 was used initially by machine gun crews, but was found to be useful by the 88mm Flak gun crews. This was a handheld portable unit capable of ranging distance and/or elevation to targets. The rangefinder Model EM-1M was man-portable and originally intended for use with the 20mm Flak, but found favor with 88 crews as well. Fire could also be directed from an OP or an observation post. The purpose of the OP is to provide target identification and range value for ground targets below the horizon or beyond 10,000 yards. In the air defense role, a much larger stereoscopic director was used to track and range aerial targets, the stereoscopic director 36 and the auxiliary director 35. Now, the 10x80 Flak spotting binoculars were primarily employed for aircraft identification, originally designed for maritime use, but gained popularity amongst Flak gun crews. During Germany's involvement in the North African campaign from 1941 to 1943, the 88s earned their reputation as a tank killer. Rommel's Africa Corps relentlessly deployed 88s to kill British tanks. The flat, unbroken terrain enabled gun crews to take full advantage of the 88's long range and flat trajectory. Depending on the terrain and the nature of the fighting, the flak battery could be constantly on the move. The challenges facing the gun crews fighting in the desert seemed insurmountable. Men and machine were pushed to their absolute limit. Fighting and surviving in the deserts of North Africa was a constant struggle, and for Rommel and his men, logistics proved to be their biggest challenge. Projecting men and material into the theater of operations was a battle all its own. The situation in the Libyan desert was summed up by German General Johann von Ravenstein, commander of the 21st Panzer Division, who described it as a tactician's paradise but a quartermaster's hell. Much of Rommel's desperately needed supplies plummeted to the bottom of the Mediterranean due to Allied attacks. Much of the fuel needed was consumed in transit by the convoy itself, desperately trying to reach Rommel's forward positions. At one time, the supply route was stretched over 1,000 miles. That's like driving from Seattle to LA. Rommel's Africa Corps fell victim to the logistical shortages of every type, eventually leading to his defeat in Africa. We talked a bit about warfare in the desert, which leads us to a pivotal battle that took place in June of 1941, a 3-day ordeal in the North African desert. British Commonwealth forces had seized large parts of eastern Libya on the border with Egypt. Italian forces were unable to defeat the Commonwealth. Germany sent its Africa Corps, commanded by Erwin Rommel, to push British forces back towards the Egyptian frontier. The port city of Tobruk, Libya, was of strategic importance for both the Allied and the Axis powers. Tobruk was the only deep-water port available, and whoever controlled it controlled North Africa. Now, Tobruk was under siege and would be for 242 days. The Allies managed to take control of the once Italian stronghold, and as one can imagine, the Italians wanted it back. British forces tried to lift the siege, Operation Brevity, May of 1941, but were only moderately successful. A second attempt, Operation Battle Axe, was launched on June 15th to push the Axis forces back, relieve the siege, and recapture eastern Libya. Halfaya Pass and Fort Capuzzo were of strategic importance. British forces launched an offensive, confidently moving through the Halfaya Pass, but were met with devastating firepower. A battery of 88mm flak guns dug into the landscape, masterfully camouflaged. They immediately destroyed 11 Matilda tanks, forcing the British to fall back. The following day, Fort Capuzzo was taken by Rommel's forces. Additionally, an attempt was made by British armor to intercept German armor approaching the Hafid Ridge. Once again, British armor was intercepted by an 88 battery. The anticipated tank battle was immediately altered, and by midday, 3/4 of the 200 British tanks deployed were lost. On June 17th, British commanders ordered an immediate retreat, narrowly avoiding a complete encirclement by Rommel's forces. Operation Battle Axe concluded in a devastating loss for the British. So what made this such a pivotal battle? Let's examine 4 crucial Allied failures. Number 1. The armored units had been severely handicapped by the haste with which the operation was mounted. Number 2. Heavy losses were attributed to a lack of training. Number 3. Cooperation between air and ground forces was found to be unsatisfactory, resulting in the loss of 33 fighters and 3 bombers. Tactics for both air and ground forces were untrusted. Number 4. Failing to appreciate Rommel's tactics, which was the use of tanks to primarily deal with troops and thin-skinned vehicles, and the task of destroying enemy tanks was largely one of the anti-tank guns. It was soon clear that the most heavily armored British tank, the Matilda, was suffering from the heavy shell of a large, high-velocity gun. In contrast, let's examine 3 Axis forces' successes. For the Germans, the 88's performance against tanks was already known in August of 1940. They tested the 88 against Matildas captured in France. Among the first to arrive in Africa in February of 1941, was a detachment of 88 guns. Number 2, a further feature of Battle Axe was that the Germans had the great advantage of possessing enough well-tested mobile equipment to recover and repair damaged tanks. And third, conversely, the British had very little recovery equipment and were forced to abandon many damaged but repairable tanks. The previously unknown threats of the 88mm anti-aircraft gun used against British armor became a strategic concern for the Allies. The future presence of the 88 in all theaters of battle led to the development of new tank designs, new tactics, and doctrine regarding armored warfare, and a greater appreciation for the gun's deployment in support of German armored units. In fact, by mid-1942, U.S. observers studying the battles near Tobruk concluded that the German 88 guns penetrated the armor of all British tanks. The British seemed incapable of dealing with these weapons. The greatest single tank destroyer is the German 88mm anti-aircraft gun. In the hands of a skilled gun crew, it was a killing machine. We must never forget that tens of thousands of Allied airmen, sailors, and soldiers did not see life beyond the war years because of the deadly capabilities of this formidable weapon. We hope you enjoyed the second episode on the museum's 88mm flak guns. Thanks for watching, and as always, please like and subscribe to our channel. I'm Dusty, and I will see you on the next one.